Hello grade 11 AS level students on minor chemistry. Today I'm going to discuss the other worksheet, which is the worksheet of chapter enthalpy changes. Now let's see the first question. Which statement about bonding is correct? The bonding which is correct is bond breaking is endothermic and requires energy. Why is it like that? It's similar to when we break something. When we break an object, we must give an energy to the object. So the object gains energy and it requires energy. Okay. Next question, which types of reaction are always exothermic? Neutralization is an exothermic. Why? Because heat energy is given out. And in decomposition, energy is given in or called as endothermic. While the last combustion is energy given out, exothermic. Okay, next question, which process are exothermic? Ice melting, neutralization, or combustion? From the previous question, we know that neutralization and combustion, both of them are exothermic because heat energy is given out. Now, let's see ice melting. Ice melting is from solid to liquid. Okay, from solid to liquid. So solid has lower energy than liquid particles. So from solid become liquid, energy must given in, and it is considered to be endothermic. Okay, next question. Some water is heated using the heat produced by the combustion of magnesium. Which values are needed to calculate the enthalpy change of a reaction? So some water is heated using the heat produced by the combustion of the magnesium metal. Which values? We know that enthalpy change is Q, can be calculated from the formula Q equals to mc delta theta. Mc delta theta is from the mass of the magnesium, mass of the water, and the temperature change. And then the specific heat capacity in here, we are using the specific heat capacity of water. Why? Because water is heated. Next question. Which substance does not conduct electricity? We know it has to be a solid zinc chloride. Why? Because solid ionic compound, they do not conduct electricity. Molten ionic compound, they conduct electricity because the ions and the electrons can move. Next question. Consider the reaction between magnesium and hydrochloric acid. Which factor will affect the reaction rate? Let's see from the option 1, 2, and 3. 1. The collision frequency of the reactant particles. There must be collision frequency of the reactant particles. What are the reactants here? Magnesium and hydrochloric acid. They contain particles, so the particle collide is important. And then the second, the number of reactant particles with energy bigger than the activation energy, so the reaction can occur. And then the last, the number of reactant particles that collide with the appropriate geometry. Appropriate geometry meaning the side of the reactant particles that collide. If they are not in the correct orientation, then there would not be any reaction. Next, when 100 centimeter cube of 1 mole of HCl is mixed with 100 centimeter cube of 1 mole per decimeter cube sodium hydroxide, the temperature of the resulting solution increases by 5 degrees Celsius. It is 100 centimeter cube of HCl and 100 centimeter cube of sodium hydroxide, both of them in the same volume and both of them in the same concentration. Now, how about of only 50 centimeter cube of this? So, the temperature change would be the same. Why? Regardless of the volume, the temperature is due to the concentration. Next, consider the following reactions. There is copper 1 oxide react with oxygen to form copper 2 oxide, and then copper 1 oxide decomposes become copper and copper 2 oxide. In here we have to find the enthalpy change of this reaction. So what we can do here, the copper is on the left hand side, so we have to change the orientation of this equation. So the copper plus copper 2 oxide become copper 1 oxide. Because the orientation change, that makes this symbol also change become negative. So the reaction would be similar, would be like this. This one, copper 1 oxide with oxygen, half oxygen, become copper 2 oxide. The enthalpy is negative 144. And then, as I said, the orientation of the equation is changed. That makes the symbol also change. So this is the overall equation. Okay. Now let's go back to the equation. So the correct answer is C. Now let's continue to next number. And then next number also there is a calculation again. Fe plus oxygen become iron 2 oxide. Iron metal react with oxygen to form iron 3 oxide. The question is asking for the enthalpy change of formation of iron 3 oxide from iron 2 oxide. So we have to change the orientation of the first chemical equation. Okay, because the orientation is changed, that makes the symbol also change. And then let's see here, there is 4 in here 2. It means this equation change the orientation and also multiply by 2. That makes this enthalpy change value is multiplied by 2 and the symbol also change become positive. So the answer would be like this. FeO decomposes become Fe plus 2 oxygen. This is multiplied by 2, change the orientation. Then this one, the formation of Fe3 oxide. So the equation the same, the enthalpy change also the same. Okay, now let's continue to the next number. Which process have negative enthalpy value? Negative enthalpy value, we know that it has to be an exothermic. An exothermic, the answer must be D. Why is it D? Because this one is combustion. Combustion is exothermic. This is neutralization is also an exothermic, while this one from gas become liquid. From high amount of energy become lower energy. That means there is energy given out. Now let's continue to next number. This is the question about the reaction between nitrogen and oxygen become nitrogen monoxide. This nitrogen dioxide decomposes become nitrogen monoxide and oxygen gas. The question is asking for the formation of 2 nitrogen dioxide. We know it becomes 2. So what do we have to do here is we have to change the orientation of the second equation. This orientation change. That makes this symbol also change or multiply by negative 1. Let's see here. This one, N2 plus O2 become 2NO, and then this is already changed the orientation. So NO plus O2 become 2NO2. So the orientation change. This is multiplied by negative 1. This is remains the same. So this is the overall equation, which is similar to this one. So the answer here is C, multiplied by negative 1. Okay, let's continue to the next number. Which equation represent the bond enthalpy between H and Br in the hydrogen bromide? This one, HBr gas become hydrogen gas, hydrogen atom gas, and Br atom gas. While this one, if HBr gas become hydrogen gas, hydrogen atom gas, and Br atom liquid. No, this is wrong. It has to be the same state. Next number. A pure aluminum block with mass of 10 gram. So mass is 10 gram. Temperature difference is 30 degrees Celsius. And then the value of C, or specific heat capacity of aluminum, is this much. Which expression gives the heat energy in kilojoule? Remember, this is in kilojoule. So from this one, M, C, delta theta, it becomes joule. In order to make into kilojoule, must divide by 1000. Because in here, Celsius, this one Kelvin, we can convert we can use directly 30. So the answer is D. Next question. Next question, number 15. Number 15 is the calculation again. Carbon plus oxygen gas become carbon dioxide. Carbon monoxide plus oxygen become carbon dioxide. The question is asking for the formation of carbon monoxide from carbon and half oxygen. So in this equation, what do we have to do? We have to change the orientation of the second chemical equation. Okay, after we change the orientation, it would become like this. Carbon plus oxygen become carbon dioxide. Carbon dioxide decomposes become carbon monoxide and oxygen gas. So this one, we do the total enthalpy. We found negative 111, and then this one according to the question. So the answer is B. Next question, number 16. Which is correct about the energy change during bond breaking and bond formation? We know bond breaking is endothermic. Endothermic is positive, and then bond formation is exothermic. Enthalpy change is negative. And then next, this is enthalpy. This is the enthalpy. This is the time or course of reaction. Statement give the enthalpy level diagram below. This one is the starting. This is the final. So we know that energy flow from the start to the end, not end to the start, but start to the end. So there is a temperature down, decreases. So the answer is reaction is exothermic, products is more thermodynamically stable than reactants. Okay. Next, which process represents CCl bond enthalpy in tetrachloromethane? The answer, it has to be D. Bond enthalpy, CCl. This is at room temperature and pressure. CCl, liquid. CCl4, liquid. It become carbon as solid, and then chlorine gas. Chlorine as gas at room temperature and pressure. Next, which equation represent the bond enthalpy of HCl? So this one cannot be this one. Why? Because this is called as the dissociate or ionization. This one also cannot, because not bond enthalpy. Bond enthalpy means one hydrogen, one chlorine. The correct answer is B, because one hydrogen atom and one chlorine atom. Next, last question. 1 gram of sodium chloride or sodium hydroxide was added to 99 water. The temperature solution increased from 18 to 20.5. We know that the specific heat capacity of the solution is, this one is the specific heat capacity of water, and this one 99 gram of water. Which expression is the correct one? 20.5 minus 18 is 2.5. And then next, the mass of the sodium hydroxide is 1 gram added to 99 gram of water. So the amount of water is 100 gram, closer to 100 gram. And then this one, 1 gram, 99 plus 1, 100. Okay, and this one specific heat capacity of water. And then next, it's multiplied by 40. Where does the 40 come from? 40 comes from the molar mass of sodium hydroxide, and then divide by 1000, because it is in kilojoule. This one, remember, per mole, it means directly. Okay, so this is the end of the discussion of the chapter enthalpy change worksheet for AS level chemistry.